Dr. David Burstein.
Thank you, Susan. Usually in a room like this, I don't need a microphone. Is that pretty clear in the back?
Yes, yes.
Yeah. I come with a loud voice, I'm afraid. The story of global warming actually goes back about 15,000 years, at the end of the last ice age. At the end of the last ice age, which was mainly in the northern hemisphere, what you had was that as the ice receded, the St. Lawrence Seaway was blocked by a block of ice. Now, the thing that you have to understand is that currently a lot of our weather is controlled by the ocean. And there is an underwater river that is produced by over-salinity in the North Atlantic, which by gravity drops down and produces this river that goes like a stitch on a baseball throughout the planet. It goes around the Cape Horn, produces a Humboldt Current. On the west coast, comes down along the Pacific, goes on the Indian Ocean, goes around the Cape of Good Hope, comes up, warms Europe and warms the east coast of the U.S. This over-salinity river has existed for a long time. What happened at the end of the last ice age was this block of ice blocked the St. Lawrence Seaway. When that block of ice melted, you had this big rush of fresh water come, blocked the over-salinity, shut down the river, and what you had was another 1,000 years of ice age in the north. What does this have to do with global warming? Well, since that time, we've been warming up. One of the more interesting things about warming up is as the glaciers get removed from the land rebounds. So, for example, I was at a pub in Britain in the late 1980s where that pub was said to have been near the ocean in the Middle Ages. It was a good half mile from the ocean. What people are seeing now is the land in Scandinavia rebounding as the glaciers are removed, the land rises because the glaciers weigh a lot. The issue of global warming has to do with basically this. Name me one thing in this room that is not produced with the emission of carbon dioxide. Our clothes, the rug, everything here is produced with the emission of carbon dioxide. A civilization that is dependent on the emission of carbon dioxide for our existence. How do you change a civilization? Well, first of all, what does carbon dioxide do? Carbon dioxide, water, and methane are called greenhouse gases because they are transparent to visible radiation, but will absorb infrared radiation. And what that means is the sun doesn't heat the earth through the air. The sun heats the earth through heating the earth, and the earth re-radiates in the infrared. And it's the infrared that we feel as heat. So the infrared radiation goes back through the atmosphere. And for example, you know that on a cloudy night, the weather doesn't get as cold as on a clear night. That's because the clouds have water, and the water reflects back down a lot of the infrared radiation that the Earth is producing. The air also reflects down. Now, it doesn't reflect all the infrared radiation. It reflects half down and reflects half up. So that the more greenhouse molecules we put in our atmosphere, the more radiation is reflected down on the Earth. Now, the reductio ad absurdum of this is Venus. Venus long ago evaporated all of its water, so that its atmosphere is 92 times the density of our atmosphere, like being down 3,000 feet under the ocean. It has a surface temperature that melts lead. It is a product of a runaway greenhouse effect where basically you got hotter and hotter and hotter. You boil away the ocean. You boil away the carbon dioxide in the rocks. So that if you look at Venus's atmosphere, it's 95% carbon dioxide. Mars is also 95% carbon dioxide, but what matters is the number of carbon dioxide atoms that you have in your atmosphere, and Mars's atmosphere is 1/1,000,000th the density of Venus's atmosphere. So there's simply fewer carbon dioxide molecules in Mars's atmosphere. If you play the same game with the Earth and ask, what would happen if we evaporated all the water and we evaporated all the carbon dioxide, we'd become Venus. We would have an atmosphere of 95% carbon dioxide. That's not going to happen with global warming. What we are doing is that we are continuing to produce more and more carbon dioxide into the atmosphere. So that if you look at a graph where carbon dioxide is increasing with time, you look at the average temperature of Earth and it's increasing with time. So the issue of global warming is an issue involved with the warming from the last ice age, plus the kick that we give to it. And the kick that we give to it is producing this gradient of increasing temperature. If you look at the highest temperatures in this valley in the last 150 years, the highest temperatures are all in the 10 highest temperatures are all the last 15 years. Global warming doesn't mean everything's going to get warm. It means that weather is going to get more chaotic. And by chaos, what you mean is this. You've heard of the butterfly effect, where the butterfly was flapping its wings in Hong Kong produces a storm in New York 10 days later. It's not completely fanciful, but it's a sense that you can't, if you look at the weather report, they give a 7-day forecast. And how accurate is the 7th day? It's not very accurate. Typically, you can forecast weather about 5 days in advance, simply because there are too many variables in the prediction. In terms of what happens with global warming, the Earth is going to get warmer. Even if we stopped today and removed all the carbon dioxide emission that we had, the amount of carbon dioxide in our atmosphere would still continue to increase for another 50 years. The reason that the Bush government doesn't want to sign the Kyoto Treaty is that how do you reverse your civilization? How do you stop producing carbon dioxide? How do you keep the same level of living that we have, but don't produce carbon dioxide? And the answer is not easily. So the issue with the Bush government would have been the same as the issue with the Clinton government. They don't see how they can get back to 1990 emissions. They don't see how they can retract without producing a big impact. Now, one of the ironies of global warming is that if you look at ice, and you look at, say, the North Atlantic, and I think those of you who have been reading up on science know that the North Atlantic ice cap is slowly melting. That ice cap slowly melting doesn't do anything to raise the level of the ocean, because that's already in the ocean, and the ice displaces in volume what it occupies. So that the ice that's floating on the ocean, if it melts, doesn't do anything. What will produce ocean rising is two things. One is, as the ocean gets warmer, it rises. So as the Earth has gotten warmer, the ocean increases in size. But if you have a melting of the Greenland ice cap, or a melting of the glaciers that are on Antarctica. Those two events will raise the level of the ocean by 200 feet. Now, the melting of the Greenland ice cap will not be tomorrow, will not be next year, will not be in 10 years. But the Earth is going to get warmer. We're in a pressure cooker situation. You're putting more greenhouse molecules into the atmosphere, reflecting down more infrared radiation. That's a fact. There's no way around it. That's a fact. The Earth is warmer now than it was 100 years ago. It'll be warmer still 100 years from now. The modelers that ask how much warmer it'll be say maybe 3, 4, 5 degrees Celsius. In other words, 7, 8, 9 degrees Fahrenheit. Now, 7, 8, 9 degrees Fahrenheit here, they say, well, okay, we turn up our air conditioner. But the difference between 28 degrees on the Greenland ice cap and 37 degrees on the Greenland ice cap is a difference between having an ice cap and having water. And that's the issue. The issue is, will the glaciers disappear? Glaciers have been disappearing from Montana. The glacier on Mount Kilimanjaro will disappear within 20 years. And people will say, well, it's natural. It's the warming of the Earth after the last ice age. Well, we're giving it that extra kick. We're putting more carbon dioxide into our atmosphere. You see the concentration of carbon dioxide increasing in our atmosphere. You see the temperature of Earth getting warmer. Now, we've done something else to the atmosphere, and it was a tractable issue so that we could solve it. I think many of you know that fluorocarbon, Freon, which was used in hairsprays and in our air conditioning, when that got into the atmosphere, the fluorine atoms got into the upper atmosphere and destroyed ozone. They acted as a catalyst to destroy ozone. And specifically destroyed ozone when it was frozen, which meant it did it over the poles. So you had holes in the ozone layer over the poles. It took, by the way, it took scientists about 10 years to convince the government there were holes in the ozone layer over the poles. They first thought that their instruments were faulty. But when it was realized it was the fluorocarbons doing it, we eliminate the fluorocarbon. So the ozone holes will come back to disappear over the next 20, 30 years. That was a tractable problem. You eliminate one particular item and you solve the problem. How do you solve global warming? You don't know. We don't know. Sequestration is an issue. You have limestone. Water contains a lot of carbon dioxide. The oceans contain a lot of carbon dioxide. That produces the foam.
Raise clams on the new seafloor.
No, the question is, how do you sequester that much carbon dioxide? It's not clear. Not clear at all. Yeah.
Is there anything that consumes carbon dioxide?
Plants. Plants consume carbon dioxide. In fact, most of the carbon dioxide is not consumed by the trees and the plants on the ground. It's consumed by the phytoplankton in the ocean. And what's going to happen to the phytoplankton as the ocean gets warmer? Yeah, it's not clear. I mean, what I teach my students is we're doing an experiment. We're asking what happens as we make the Earth warmer. Like all good experiments, we don't know what the result will be. Now, factor in the issue of the sun. The sun is the source of all of our energy. There was a period of time called the Maunder minimum, which occurred in the 1600s, where the sun, which was then being observed for sunspots, didn't have many sunspots. Called the Maunder minimum because they didn't have many sunspots then. In that period of time was when the Thames froze over, when you had cold summers. The Earth was colder then. In terms of when the sun is warmer and when it's colder, the sun goes through a 22-year cycle where it becomes active, quiet, and it's a 22-year cycle because the sun reverses its polarity in that 22 years. It takes 22 years to get back to the same polarity. The sun is actually putting out more energy when it's active, when it has a lot of sunspots, than when it's quiet. The difference in energy is about 1%, and that 1% was enough to produce freezing of the Thames. So the sun has long-term effects as well. We've only monitored the sun for the last 350 years. If the sun has long-term variability issues that are much longer than that, we don't know about them yet. And it's hard for us to measure them in other stars because they're very small effects. Big effects to us, small effects of other stars. It's an issue that what the models show is that it's possible for climate to become chaotic and switch over to another issue, switch over to another form. For example, the Ice Age is when climate switched over to being cold. A different situation for Earth, but it was a viable climate, and it was a cold climate. What happens if we make the Earth too warm? We don't know that experiment yet. One of the ironies is, if the Greenland ice cap melts sufficiently, where does that fresh water go? To the North Atlantic. It shuts down the underwater river. You shut down the underwater river, and one of the ironies of global warming is you produce another ice cap in the north. So one of the ironies of global warming is you may indeed produce another ice age in the north. Yes.
Is there any validity in the models that say that as the global warming takes place, there will be more snow, and it will increase the ice caps in the Arctic and the Antarctic, and that it won't raise the level of water in the ocean?
The problem is that the global warming comes from the heating of the Earth and the Earth irradiating in the infrared. And the molecules, it just matters on how many molecules in the atmosphere can absorb that infrared radiation. We're putting more and more molecules of carbon dioxide into the atmosphere. It's producing more and more methane into the atmosphere. And by the way, you're also evaporating more and more water into the upper atmosphere. And all three are greenhouse molecules. So whatever you do to reflect light back in the northern parts of the world, that's a small fraction of the area that's being heated. Most of the Earth is not in that area. Yes, Susan?
Could you talk a little about the Kyoto, I don't know if you're ready for questions or not.
Yeah.
The Kyoto Accord, what it is, why we didn't sign it, and what are we going to do with the village that's missing
The Kyoto Accord was an accord signed by many of the underdeveloped countries saying that to keep their carbon dioxide emissions to the 1990 level. We didn't sign it because we didn't see any way to get our carbon dioxide emission back to the 1990 levels. It has little to do with who's president, has a lot to do with the fact that no one has any good ideas how to do that. And if you sign the treaty, you're committing this country to move back to the 1990 levels. There's no way that we can commit ourselves.
Why can't we move back to the 1990 levels? It's only
15 years ago?
Yeah. What, was it
Well,
too many cars? Cars?
but it's not just cars. Most of the carbon dioxide comes from plants, electricity. You have more people, you have more electricity. What's the population of the world right now? It's 7 billion. 7 billion, on its way to 10 billion, on its way to 12 billion. The population bomb has already hit, it's here. Yeah.
Well, how did other industrialized countries decide to move back to the 1990 level? What specifically are they doing or planning to do that we did not agree to do?
What fraction of our energy do we get from nuclear plants in the U.S.?
30?
12%.
Well,
What fraction of nuclear energy is provided in Europe? About 40%. And nuclear energy doesn't produce carbon dioxide. That's how they thought to do it. Hydro produces some, not a lot.
I was wondering, how big were the glaciers when the dinosaurs were running around?
Well, the Earth was warm then.
That's what I understand.
Yeah. The Earth had more carbon dioxide in its atmosphere then.
What caused that?
Well, it's not quite volcanoes. The Earth has gone through many periods of ice ages and inter-ice ages. In the ice ages, there's something called the Milankovitch theory, which says that the tilt of the Earth's axis relative to our orbit around the sun is what produces the seasons, right? That tilt is continually changing. And if that tilt, currently at 23.5 degrees, becomes close to 21 degrees, you can switch over to a different climate. That's the idea that you have a feedback and you switch over to a different climate. That's the Milankovitch theory. And it says that happens once every about 110,000 years. Well, what's the interval between ice ages? About 110,000 years. There's a number of things that we have that we know that we don't know. Yes.
David, would you say switching to nuclear energy would have a significant impact then? And if so, what do you think about Americans' opposition to nuclear energy?
Switching to nuclear energy raises other issues of where do you store the spent nuclear fuel. And you notice how good we have an agreement of where to put our spent nuclear fuel. It's a thorny issue. Wind, hydroelectric, minimizes carbon dioxide emissions. Basically, generate electricity by spinning something. By spinning a coil inside of a coil. That's what a generator is. It's how you generate that energy to spin it. You generate it hydroelectrically, pushing water through. You generate it with a wind turbine. You generate it from heat from a nuclear reactor, or do you generate it from heat from a coal-fired reactor? Or a natural gas reactor? Well, coal-fired natural gas, what are their products? Carbon dioxide. What happened after 9/11? Remember, after 9/11, there was a week where no airplanes were permitted to fly.
Unless you were carrying Saudis.
Just the Saudis.
But no airplane, that you didn't have airplanes in the sky, and people noticed in the east that the air became clear.
Sure.
There weren't as many particulates. If you go to the east, you notice that it's always hazy. There are a lot of particulates. There are pictures of the Alleghenies taken from the Richmond area, from the 1930s to the 2000s. And you see the difference. You see the difference in haze. We produce a lot of haze. We all have cars. Our cars have tires. How often do we replace the tires? Well, those tires wear down. Where do all those particles go that wore down?
Everywhere.
Everywhere. We're a society built on friction. And friction produces particles. We're a society built on carbon dioxide. So the real question is, how do we deal with an intractable problem? It's not an easy solution. If it were easy, we would have done it. It's not an obvious solution. If it were obvious, we would have done it. We haven't. What's going to happen over the next 50 to 100 years, the Earth is going to get warmer. On average, it's going to get warmer. Doesn't mean that here we're going to get warmer.
What do you think will happen here?
Not clear. Not clear. The models are not that specific as to specific areas. Weather is chaotic. Could you push the weather to a much hotter region here? Well, remember in the 1100s, 1200s, the Anasazi were taken out of this valley because there was a 40, 50-year drought. What happens if we have a 40, 50-year drought, of which we're on the first 7, 8 years of?
We bring some water from the Gulf of California.
Well, it's going to be interesting.
We probably won't have to. It'll probably be here.
Desalinization, but water restrictions. I'll tell you, when I was in Santa Cruz, we had water restrictions. When I was a student in Santa Cruz, we had water restrictions, and the way they did it was they said, well, we're going to take what you consumed in water last year, and you get 80% of it this year.
I just wanted to understand something. The wind and the hydroelectric energy, do they produce CO2?
No.
No.
So that's definitely an option.
Yeah. Hydro produces evaporative water so that you get more greenhouse molecules into the atmosphere, but it doesn't produce CO2. But wind can only produce so much energy, and hydro can only produce so much energy.
So as the climate gets more chaotic, will there be more wind that's produced?
Not clear.
It's not clear.
Not clear.
And
But those
where?
are probably two of the best options. Would you agree?
Well,
As far as clean energy goes?
the issue is, can we move from a central electricity distribution, which we currently have, to a distributed system where each of us produce our own energy?
We can, probably.
We can, but how do you do it with 1 million homes in this valley?
Well, they have to put restrictions, I think, we have to work in accordance with the capitalists and put some restrictions on homes
the
that are built in
magic
certain
word.
areas. We have to enforce laws that are going to think about the environment as well as the economy and form some sort of balance between the two. You know, the two as...
But you're going to have to be able to get the ability of a single home to generate its own electricity, and we don't have that yet.
Well, actually, Anthem and other places have homes with solar roofs, and the SRP will allow any home to be, as long as they have an approved interface to generate power into the grid.
Right.
If it does have the solar or wind or
Well,
whatever.
solar
people allow
arrays are
that,
not
aren't they,
very
generous?
cheap yet.
Right.
Not as cheap
They'll allow it.
as being able to essentially generate energy. Once they get as cheap as being able to essentially generate energy, then you'll see solar cells everywhere.
Wouldn't a solution or a method to seeking a solution really encompass lots of things? I mean, hydro production, wind production, but also conservation, which is not a popular word in the last 10 years.
Well,
Did y'all hear that back there?
what do we do in Tempe? We recycle. We have one bin for recycle, one bin for garbage. And our bin for recycle is as supplied as the bin for garbage. But even then, you're recycling, but you're still producing the CO2 emission. And when we were kids, what was the population of the U.S.? 150 million. What's the population now? 300 million. Population of China when we were kids was 800 million, 1.6 billion. China did an experiment where they limited families to one child. The experiment failed.
Maybe education is another factor in that. People understand what we're doing to ourselves. It kind of,
Right.
yeah,
Right.
okay.
Right.
Was that really a failed experiment in China, or wouldn't it not have been much worse had they not done that?
It would have been 2 billion instead of 1.6 billion.
So is it fair to call it a failed experiment?
It's a failed experiment because the vast populace, China, of the 1.6 billion people in China, 1.3 billion are in the rural areas, and rural means rural. I've been to China. I've seen the rural areas. Rural is rural, where houses are built of rocks stacked on bricks stacked upon one another with no cement. If you ask, how did 300,000 people get killed in an earthquake in Tianjin in 1976, all their houses were like that. They just collapsed. Most of the population of China is rural, so it's not producing a lot of carbon dioxide. It's living off the land, basically. But 300 million Chinese are becoming like the U.S.
That article that I sent around, I don't know where it is, Bill Moyer's talk. If you read past, I think, the first page into the second page I mean, this is somehow tied up to Christian evangelism, I'm sorry, but it is. And they're preaching a philosophy of laissez-faire, we don't care, put your head in the sand, it doesn't matter, the earth will take care of itself, God is looking out, don't worry, pollute, do all this stuff. How do we overcome that? This
Well,
kind of prevalent attitude, especially, not just within
what's
Christians.
interesting is that I don't think that's a prevalent attitude in Germany or in Poland or in Bulgaria or in Russia, where they destroyed their environment.
But we're the biggest users in the world, and we're the ones with the attitude.
Can I comment on that?
Yes.
I think as a Christian, I feel that more than an attitude of the earth is going to take care of itself, I see more Christians saying it's going to happen anyway. God, it's in the Bible that all this bad stuff is going to happen. So, which I personally feel that I don't care if it's in the Bible or not that it's going to happen. I want to do as much as I can to prevent that from happening. to take care of the earth and to take care of myself and, preserve this for future generations to the best of our abilities. There's so many other variables that could, we could get hit by a comet and, go into ice age or whatever. So, but just, I guess what I'm saying is like, there's two types of thought that I see, and I think more with Christians, it's like focus on spiritual, focus on saving yourself for the afterlife, and not focusing on, recycling or being concerned about the environment. And I think like the best way to really overcome this is like that one lady was mentioning, to educate. Like we really have to go out and we have to educate young people in the colleges, in high school. I learned a lot in elementary school about recycling. And in each state, I just feel like we really have to educate ourselves as to what can we do, the small things that we can do every day. And really, there has to be a strong force, I think, in the education system, I think is the best route to go. And also in the governmental system. I think that the government really needs to start enforcing recycling. There's states that, like I heard Oregon, that they're really big on recycling. Why doesn't every state have some sort of, why isn't there a consensus between all of the states on recycling and conservation, water usage, all of that? And like the building of the homes in Arizona, it really amazes me that they're allowed to build so many homes in the desert. It just doesn't make sense. Like why is the government allowing these things to happen? And
It's called capitalism.
yeah, well, I just really believe that somehow, some way we can convince the capitalists that.
No, you can't. You have to own all the newspapers, and those are already owned by things. You have to own all the media. You have to own the coal company, the oil company, and the nuclear power companies. Those are all owned already by the people who set policy. That's why.
Do you think that the capitalists care about their life and the life
No.
of their grandchildren?
No, they care about the green.
Care about the money. Right
David,
there.
how about your opinion on this?
I don't have to. You're already seeing the reason that people are going to hide their head in the sand is that there's no viable solution. What happens when, you can see this in an elementary school when it gets a principal who doesn't know how to lead? What happens? Everybody fractionates. Everybody fractionates within the school.
Well, if the Earth's population was reduced to, let's say, 1 billion, wouldn't that solve the problem?
Yeah. Right. How do you reduce the Earth's population to 1 billion?
Maybe you consider war.
Global warming?
Maybe some kind of virus that starts with the Earth and takes care of it.
Do we know that would solve the problem?
What? One
Go a
billion.
long ways to solve it.
Well, it would reduce CO that's generated by human activity. But with that kind of certainty that we're not going to heat up the earth.
Well, the question is, how do you reduce it to 1 billion and not have it grow to 7 billion again? And that's part of the problem. There was a book published by Paul Ehrlich called The Population Bomb that was published in the 60s. Population bomb has already exploded.
Yeah.
You already alluded to it, individual power plants and all this stuff. What we need is awareness of the problem, and we need education, and it means educating people who don't believe in...
Get rid of the Republicans.
There's so many advances, like in photocells, and there's looking to be a breakthrough in hydrogen production and storage. These things could work, but the people don't want to mess with it. For the most part,
Technologies are already
you've
owned
got to
by
have
the same
everybody
people.
producing their own power, like you
And
said.
they make profit.
Well, hydrogen, for example. People would want to go to a hydrogen economy. The problem is that the fuel cells that they have are not as efficient as they want them to be.
But the ones of the future will be.
Matter of life and death.
There's enough technology there.
The the future has to be what we produce.
Yeah, but
And
the technology is there in the experimental stage right now.
in the experimental stage, but the question is, can you produce it in large scale?
That's the problem.
Now remember that the gasoline issue, 100 years ago, there weren't gas stations.
No.
There literally weren't gas stations. That is all built up. How do you supplant it?
Well, they're tearing them down as fast as they can now.
How do you supplant it? It's not easy. How many places have liquefied natural gas that you can fill up at? That's the technology that's already here, that you can convert your engine to run on liquefied natural gas. How many places can you fill up with liquefied natural gas? How many gas stations can you fill up with?
When you talk about solar power and hydrogen power, can these things be manufactured without adding to the hydrocarbon problem? In other words, what does it take to build these things in the first place? Can they be built without producing?
Let's put it this way, they can be manufactured far less than what the plants put out.
That requires
It requires, how did we get agreement on the Freon issue?
Recognition that it was a real problem because we.
And then what happened? The government set in and said, thou shalt stop making Freon, and thou shalt make air conditioners without Freon and spray cans without Freon, and ban it. They banned it. Until we get the government to get some agreement of what to do, nothing's going to happen. And you see what happens when Congress has hearings on global warming. You get the yay and the nay. You get the people who want to hide their head in the sand. You get the people who are predicting bad things. It's somewhere in the middle.
By the way, Freon is not gone. It's just gone up
Yeah.
to about $900 a can or something like
Yeah,
that.
yeah,
That's how you get it done.
yeah.
What is the forecast on how long our oil supply lasts? I mean, I think it's pretty limited,
Which is a good thing.
so maybe things take care of themselves.
There's gas and coal into the US.
Yeah. There's ideas that there may be non-organic hydrocarbons that lie 50, 100 miles under the ground. What you think that as soon as people start running out of easy access to hydrocarbons, they start drilling 50, 100 miles under the ground? That's a long way. We don't have the capability yet, but I bet we get the
And
capability.
the impact of that,
Pardon?
and the impact of having all these old,
Higher gas bill.
What's the impact of nuclear fuel? The thing is that to generate energy, you change one thing into another. Electric cells change photons into electricity. And the reason they're expensive is it's expensive to change photons into electricity. A wind turbine takes the motion of wind and changes it into a turbine, which changes it into electricity. Hydroelectric power takes water, which turns a turbine, which changes it into electricity. Coal-fired plant heats up water, sends it through turbines, produces electricity. Nuclear fuel heats up water, sends it through turbines, produces electricity. What happens when we have a power outage? We've had power outages in the valley. What happens? Everything goes, right? Computers down,
That's the worst of it.
Yeah, right.
Traffic lights.
The best of it.
We're a society built on electricity. We're a society built on electricity, on the availability of electricity, on the availability of electrons going through wires. That's what electricity is, yeah.
I was just wondering, are there any groups of people that are working on like plans to implement some of these changes? Are there any like well-recognized groups, maybe outside of the government, or?
Well, there are scientists that are looking into ways to better sequester and make fuel cells more efficient with hydrogen.
But what
And
about what about overall plans, instead of just looking at one thing, like, okay, how can we produce cleaner energy, but like actually implementing on a large scale different things that people can, that society can do to live cleaner and work together to.
And get the current legislature of our state to agree on that? Yeah. As reactionary as it is, to get the current legislature of the U.S. to agree on that, when most of them don't understand science in the first place.
It's a problem.
And the question is, how do you convince the lawmakers to do something when you have reputable scientists get up and say, nothing's going to happen?
People want to hear that.
Yeah. People don't want to be told doom and gloom. They want to be told things are going to be peachy rosy.
He's coming.
But we're producing a pressure cooker, folks. We're putting more greenhouse molecules into our atmosphere that produces more radiation down to the Earth. The Earth is going to get warmer. To us astronomers, that's simple astronomy.
There's a paragraph from this I'd like to read. This is from the Bill Moyers thing. It goes along with what you're saying. He says, I read that the administrator of the U.S. Environmental Protection Agency has declared the election a mandate for President Bush on the environment. This for an administration that wants to rewrite the Clean Air Act, the Clean Water Act, and the Endangered Species Act, protecting rare plant and animal species and their habitats, as well as the National Environmental Policy Act that requires the government to judge beforehand if actions might damage natural resources, that wants to relax pollution limits for ozone, eliminate vehicle tailpipe inspections, ease pollution standards for cars, sport utility vehicles, and diesel-powered big trucks and heavy equipment, that wants a new international audit law to allow corporations to keep certain information about environmental problems secret from the public, that wants to drop all its new source review suits against polluting coal-fired power plants and weaken consent decrees reached earlier with coal companies, that wants to open the Arctic National Wildlife Refuge to drilling, increase drilling in Padre Island, on and on and on. He learned this week, it says, how the Environmental Protection Agency had planned to spend $9 million, $2 million of it from the administration's friends at the American Chemistry Council, to pay poor families to continue to use pesticides in their homes that have been linked to neurological damage in children. But instead of ordering an end to their use, the government and the industry were going to offer the families $970 each, as well as a camcorder and children's clothing, so they could serve as guinea pigs in the study. This is from Bill Moyer's talk. Now, I don't know if every word of this is accurate. This is what we're fighting. Okay.
You've talked quite a bit about the greenhouse gas and its effect. One of the other things I've heard people express a concern about is merely the conversion of stored energy, such as in petroleum, to released energy, because we use it and then that heat comes into the atmosphere. Is that a significant part of this problem?
That's not a significant part.
So that's really kind of a red herring of some
Well,
sort in the trade?
well, ask yourself, when does it get cold?
In the winter.
When does it get cold in the 24-hour period that just passed? Nighttime. Why does it get cold? We don't see the sun. The sun is the source of basically almost all of our energy.
Yeah, you're starting to get into the astronomy thing, and I'm thinking of just, to further ourselves, we need hard research, theoretical research. And what's the impact of having to use more different spectrums of filters to finding out different energy levels in different spaces in astronomy? And how much does that get to hard science?
Well,
Theoretical science.
astronomy comes into play because we see what happens on other planets. We see what happens. Basically, I give a tale of 3 planets, Venus, Earth, and Mars. Venus is a runaway greenhouse effect in one direction. Mars is a runaway greenhouse effect in the other direction. Earth is called the Goldilocks planet. Now, can we ruin the Goldilocks planet? It's not clear. We're going to get warmer. It's not a myth, it's reality. We're going to get warmer. The Earth as a whole is going to get warmer.
That's inevitable in the cycle of the universe.
Well, no. It's inevitable from what we are doing in terms of producing carbon dioxide in our atmosphere. We are really pushing the issue of the warming from the last ice age.
Well, we're just accelerating it with man's efforts. If man were not doing his efforts, manufacturing efforts, we would still be in this cycle between ice age and warming and ice age.
Yeah, but we probably wouldn't be warming as much as we are.
You're kicking it up.
Yeah.
Well, what about all of the methane locked in the permafrost? If that heats up a few degrees and all of a sudden all of that's released.
Well, you have the problem of all the methane that's locked in the ocean. Yeah, it's interesting.
Were there periods in the past where we had greenhouse gases in the atmosphere in excess of where we're at now?
Yes.
That's what I thought.
Yeah. During the time of the dinosaurs. Then it was warmer.
I'd like to follow up
By
on
the way,
that.
the sun is gradually getting warmer. The sun is getting more luminous. So 100 million years ago, the sun was not as luminous as it is now. And so for the Earth to be warm then, you had to have much more of carbon dioxide in the atmosphere.
I'd like to follow up on the nuclear energy possibilities, since it seems to be a very real one, we already do it. If we were to switch to nuclear power, do we have an unlimited supply of raw material for that?
The issue is we haven't put the amount of research and money into nuclear fusion that we should have. And if you can get a viable nuclear fusion issue, then you have unlimited resources.
Oceans full.
Because all you need is oxygen, and all you need is hydrogen, and deuterium and tritium, and you get that from seawater. We basically have a break-even issue with the fusion reaction, where you put in as much energy as you use to generate the fusion. You need to be more than break-even. And you need to have a way to contain the fusion. There are ways around to do it, but it's not easy to get.
Well, it seemed like when we were talking about the Freon getting into the upper atmosphere and screwing things up in some fashion, the solution was to stop producing those molecules so they wouldn't be up there. And you're just now saying that, the sun's going to get warmer and the greenhouse gas is trapping it. It would seem like a solution, if someone could control it, and it could be done at all, would be to put something into the upper atmosphere that reflected some of the energy back out rather than letting it in. And it sounds like we're only dealing with small percentages. Is anybody looking into some aspect of that?
First of all, how do you get into the upper atmosphere?
Send a missile.
How do you get, say, mirrors into the upper atmosphere?
Well, I'm thinking more of molecules, some kind of something up there that
There are no molecules that we know of that reflect visible light. That reflect enough visible light. White clouds can reflect visible light. What are white clouds made of? Water.
But they have to be clouds in order to do that.
That's right, yeah. By the way, why are clouds made of water in our atmosphere?
Because God said so?
No?
She told me she didn't.
Yeah. Because water can be both gas, liquid, and solid at the temperatures in the atmosphere. And so it can condense from a gas to a liquid in our atmosphere. Why our atmosphere is not made of clouds of oxygen or nitrogen, which are a much higher percentage of our atmosphere. It's made of water, which is a minor constituent of our atmosphere.
Yeah, I'm getting back to the, I'm a techie, what do you want? I'm getting back to the science thing. You talk about, fusion. You're talking about, individual power sources. It all takes stuff for the future. What if we had fusion, our energy needs would be met? What about superconductivity? We're not putting any research into these things that would solve the problem.
Well, people are looking to find out if there is room temperature superconductors. Right now, the best superconductors that exist in liquid nitrogen.
Yeah.
The highest temperature. And so the idea that you produce superconducting trains on superconducting rails, there maybe is 3 or 4 miles of such trains available, and mostly in Germany.
Right.
So it hasn't come yet. You have to have a way to easily do it. And you don't have a way of easily doing it.
There's some means of doing ceramic wires that it seems to say, okay, if we put enough research into it, we can do it.
Well,
But we haven't put the research there.
The question is not so much putting enough money into it, it's putting enough ideas into it.
Yeah.
And we're going to have a School of Material Science at ASU. The astronomers are moving to a School of Earth and Space Exploration with the geologists, a few engineers, and a few life scientists. So the idea is to start getting collaboration as well. And if we start getting collaborations, where will that lead to? It's not clear.
Step in the right
Not
direction.
clear. You have to understand better why materials produce what they do. We have an imperfect knowledge of it. We need to get a better knowledge of it.
One more question.
Fine.
So one more question. We have one more question.
Where would you say that Poland destroyed its environment?
All right. When Poland was part of the Soviet bloc, and you were there, and it used a lot of its environment willy-nilly. Not as much as Russia did, not as much as East Germany did, but it still did. And now it's paying the price for it.
Russia, by the way, is doing it again.
All right?
Russia, by the way, is doing it again still.
Yeah. Well,
In the Ukraine.
Any others? Thank you.
If you appreciate the Humanist Society of Greater Phoenix and would like to see more, then subscribe to our channel and check us out on Patreon. Links are in the description.